So here at the bottom of page 2, we're introducing the Combined Gas Law. And you see the equation here written on your page. We'll also have that on our equation sheet later. This does tell us that in addition to the P's, V's, and T's that we're used to seeing already, we also have an N in this equation, or two N's. An N represents moles. If you want to add a reminder that P is pressure, V is volume, and T is temperature, then that would be great. You do not have to, though, because those are a little bit more obvious. But if it helps you, write it. What I would like everyone to write is how, or really when, to use the combined gas law. I know this is the first one that we're learning about, but we are going to learn about 3 or 4 more gas laws, equations that we're going to be using to solve problems. And so one of the important things by the time we get to the end of the unit is that we remember when to use each of them. So this combined gas law is going to be used when our pressure, volume, temperature, or moles are changing. And like we just saw on worksheet 9A, probably, usually 2 or more variables are changing together. So we can use the information that we know about the variables that are changing to figure out any information that we don't know about the other variables that are changing as a result. So that's going to be important. Now, our temperature units, like we talked about before, have to be in Kelvin, the whole unit long. Every time you see Celsius, turn it into Kelvin. And all we've got to do that is add 273. So you'll see me doing that several times here. Now, of course, moles are N, like we already said. Pressure and volume, though, can have lots of different units. There's not just one type of unit that we can plug in for pressure or volume. They're flexible. They can be anything. But what is important about those units is whatever units I use for my P1 and V1 have to be the same units for the P2 and V2. So P1 has to match P2, V1 has to match V2, and for the most part, most problems give you matching numbers with matching units, but we have to be on the lookout for that just to make sure that they do match. That's probably all that you really need to write here before we move on to the next page, where we're going to be working out some examples, but what's already written down below this equation for you is telling you to cross multiply in order to solve this problem. We're going to be plugging numbers in here, and what we mean by cross multiply is multiply across the equal sign on a diagonal. So if we plug numbers in for everything here, we'd be doing P1 times V1 times N2 times T2, and then we'll set that equal to the other diagonal, N1 times T1 times P2 times V2. So we're going to cross multiply and set those two things equal to each other. And then, like it says, you're going to end up having to divide in order to find the specific unknown that you're looking for. And I will do this several times in the next page so that you can kind of get that practice. And let me know if you need help cross multiplying and dividing to find these answers. Now, the best thing about this big crazy equation is that it doesn't have to stay big and crazy. If a variable doesn't change, this is those last 2 bullets, it's already written for you, I just kind of put them together. If a variable does not change, so the problem says the temperature does not change, or the temperature is held constant, or if that variable is just not addressed in the problem, not mentioned in the problem at all, then we don't put it in the equation. So if a problem says the temperature is held constant, then we don't have to put in a T1 or a T2. Don't start making up numbers for them. Just leave it out of the equation. And the other stuff that is left, that is changing, just becomes our new equation. So if they don't mention temperature and they don't mention moles, the N's and the T's go away, then our equation can get real simple, real short, and we just have to plug in our P1 and V1 to find our P2 or V2, whichever one we're looking for. So you have permission and the kind of ability to take anything out of this equation that you don't need. But you have to read the problem first to see if the problem needs all of those letters there or not. Now, this is our first equation, so you're probably not worried about memorizing all of this stuff quite yet, But just to set your mind at ease, you do not have to memorize this big crazy equation. You're going to be getting this equation sheet as a copy that you can hold and use on your own and on every test from here on out. And that equation is sitting right there waiting for you to use. And I actually want to point out underneath it are some equations we won't need to use ever. They're just variations on this combined gas law. Some people teach kids when to choose to use one or the other. What we just tell you is use the big one every time. Make that your default, but you can always just simplify stuff out so that what you're left with looks basically like those equations. So we'll get that later, or maybe you already have it. So let's go ahead and flip over to page 3. I'm going to work out almost all of these problems with you and for you. And just in case you get it and you're like, okay, I'm done, I can stop this video and move on without her. I wanted to give you the answers to all the problems on this page so that you can keep going at your own speed and check things. And as long as you can get these answers, you don't necessarily have to walk through these problems with me. But let's go ahead and work the first one together at the very least. Notice I have those answers pop up on each slide, but if you are done with me before I get to that slide, you can always just flip back to those answers and use them to check your work as you go. And I have my equation up there at the top of the page. If you want to open up your packet to kind of a 2-page spread, then you should be able to see that equation on your page 2 while you're working out these problems on page 3, and that might be helpful. Now, what I'm actually going to start with each of these problems is reading through it and noting where each of these variables is. So I actually want to label things as P1, V1, P2, V2, so that I can pull all the numbers out of my problem and put them in the right space and make sure that I don't make any silly mistakes. So, as we read through this first problem, it says that I initially have a gas at a pressure of 12 atm. So it tells me that's pressure. It's the first pressure that I've got, so I'm going to label it P1. At that pressure, my volume is 23 liters, so that's going to be V1, and a temperature of 200 K. That can be my T1. Now, I know we haven't done it here, but just in case, for whatever reason, someone decided that this was P2, that's perfectly fine. It's not a big deal, as long as you also make this V2 and T2. They have to go together, no matter which side of an equation they're on. This equation tells us one side is equal to the other. It doesn't really matter which side they end up on, as long as these 3 specific numbers end up together. As we keep reading, evidently we then raise the pressure to 14 atm. That's the second pressure I've seen, so I'm going to call that P2. And increase the temperature to 300 K. So that's going to be my T2. And then it asks us, what is the new volume of the gas? That evidently sounds like we're going to solve for V2. So that is every number that I see in the problem. And, I didn't write down any N's. N is moles. I don't see moles anywhere in this problem. It doesn't even mention them. So, if you remember, that means we can leave them out of our equation. And it's actually pretty common to leave out N in these situations, but, he has to be there anyway just to be part of the equation. But we can leave them out whenever we want. So, that is our new kind of shorter, simpler equation. And now at this point, we're just going to put all of these numbers in where they belong in that equation, one by one, in order to get our equation set up. So I am going to do this down below in green. So we're going to start with our P1, which is 12. V1 is 23. And I like to separate my numbers with parentheses. If you'd prefer to write out 12 times 23 divided by 200, that absolutely works. I just know some people like to use x's as variables, and so I try not to use any x's unless they are something that we're solving for. So I like to just put them in parentheses. And I can put it in my calculator that same way, but I do still write in my calculator 12 times 23. Anywho, getting distracted here. Let's finish setting up our equation. P2 was 14. V2 is what I'm looking for. And even though I don't have a number for it, I do need to write either V2 or X, if you prefer, in my equation. And then my T2 is 300. So this is what I expect to see. This is the absolute minimum that I need to see written on each problem that you work out, as the numbers from the problem substituted in to our equation in the right places. Now, we need to cross multiply in order to actually solve for V2. So we're going to be multiplying across each of these diagonals. So 12 times 23 times 300 is 82800. And if I multiply across the other direction to set that equal, 200 times 14 is 2800. And that's also the cross where my V2 is. So I need to include V2, or X if you called it X earlier, here with the 2800. That's really important that we put it in the original equation and that it follows with the numbers that it's starting with when we put it in our cross multiplying equation and kind of set it up here. We have to have that variable written there, even if it's an X, so that we can solve for it. If we don't include that in our equation, that's kind of like playing hide and go seek with your friend when you didn't invite your friend over to play. They're just not there. How are you going to find them? It's just not going to work. So even though we don't have a number for it to plug in, that's the whole reason we're doing this. We're looking for a number for that variable. So we have to put it in our equation so that we can get a number that it's equal to. So we have to put it in there. And at this point, we still haven't quite found V2. He's still kind of hiding, but the only thing hiding V2 now is that 2800. So to get rid of this, and one of the reasons it's so important to write the unknown variable is because at this step, after you've cross-multiplied, we're always going to be dividing by whatever number is with the unknown that we want to get by itself. So here we're dividing by 2800. If we do that on both sides, of course, 2800 divided by itself cancels out and just leaves us V2. We found it. We've gotten it by itself. And all that we need in order to find a final value and get our final answer is do this top divided by bottom. 82800 divided by 2800. And that'll actually get you something more like 29.5 or 29.6. But if we did have that 29.5714, we would know that we'd need to round that to two significant figures, because if we look back at our original numbers, we had a lot of numbers given to us in the problem. A lot of givens means we need to look at all of them, and we keep the fewest number of sig figs out of all of them. So 12, 23, and 14 were all two sig fig numbers. Even though 300 and 200 had 3 sig figs, our answer needs to be rounded down to 2 sig figs, because that's the least number of sig figs as any of our givens that we started with. So if I wanted to just keep two numbers, 29, the 5 is going to be rounding our 9 up, so that becomes 30 there. And as long as I got my decimal there, that is two significant figures. And then the units here, 30 liters. I know that the units on my V2 are going to be liters because the units on my V1 were liters. Remember how we said that our volume and pressure units have to match. And that's kind of a rule for us when we're plugging in numbers, but it also helps us find the units for them, because they could be anything. They will always match. Your V2 units will be the same as your V1 units. Your P2 units will be the same as your P1 units. So just look with what you're started with, and that'll be what you're ending with. not too bad, I hope. I know there's a lot of numbers, but if you label them as you read the problem, then it's pretty simple to put them where they belong. Let's look at another example with a couple of little twists in here. As we're reading through, it tells us that our gas has a volume of 28 liters, so that's going to be my V1, a temperature of 45, that's my T1, an unknown pressure has its volume increased to 34 liters, so that's my new volume, my V2. Its temperature is decreased to 35, so that's my T2. And then the pressure after that change is going to be 2. So, of course, that's a pressure, and it does specify that's the pressure after the change. So after my volume has been increased and my temperature decreased, which means even though this is the first pressure number I'm seeing, this is going to be my P2. Very, very important. And you might have realized when it was talking about an unknown pressure at that original V1 and T1, even back here, you might have realized that we were probably going to be solving for P1. But it went ahead and made it very clear by the end. We're looking for the original pressure. The first pressure there is what we're solving for. So either of these would give you the clues you need to figure out that you're solving for P1. The other thing that we have to remember to do before we start plugging these numbers into our equation, which it seems like we're going to be able to leave out our moles again, is turn our temperatures into Kelvin. We cannot use Celsius temperatures here. Does not work. Won't get us the right answers. So what I tend to do is actually fix these. As soon as I write down and label this T1 and I notice that it's in Celsius, then I go ahead and I take 2 seconds and add 273 in order to turn that into Kelvin. And when I add 273 here, it gives me 308 Kelvin. So now these are ready to be plugged into our equation and set up. Our P1 is what we're solving for. So I'm going to leave that written out with its letters, put numbers in for everything else. Our V1 was 28. Our T1 in Kelvin was 318. Our P2, it was 2. Our V2 was 34. And our T2 was 308. So, setting this up this way, we should be cross-multiplying and setting these two sides equal to each other. And that should be able to get us to our final answer. But I am actually going to leave you at this point, just a general reminder of how to set up and solve this cross-multiplying, and tell you that our answer should be 2.5. Which comes out pretty much at 2.5 if we've done this correctly. And of course, ATM is going to be the units on our P1 because that was the units on our P2. They have to match again and always. So go ahead and keep setting that up. Start developing your own process for what to do between setting up your equation and solving for it. Because I know I showed all the work that I did a specific way, but cross-multiplying and dividing the way I do it isn't the only way to do it. And honestly, I don't have to write anything down between my original equation and my answer. And I don't need you to do anything between them either. So just practice what you need to do. Practice trying to get from the setup to the answer. And if you're struggling with that process, let me help. But it's important to me to do less and less with these so that you can be doing more and more with each problem and starting to assemble your own processes so that you can work these problems on your own without any help from me. Question number 3 has a pretty big twist in it. If you start trying to work it out, it looks pretty straightforward, although this is the first time they just haven't bothered to tell us at all what this number represents, but hopefully you're familiar enough with liters at this point to recognize that's going to be our V1. And it's nice enough to tell us this is our pressure and our temperature. And oh, they were even nice enough to turn that into Kelvin. How nice. And it's asking us to find the volume of our gas after we decrease the pressure and our temperature to STP. So, I can tell it wants us to find V2 here again, but I don't have any of my other two side of my equation. No other T2s or P2s here. I'm kind of fine with not having N's anymore. I'm pretty comfortable with that. That happens a lot. But I have to have a T2 and or a P2 in order to be able to work this out. And right now I have neither. But it is trying to give them to you. And everything you need is hidden right here in these three letters, STP. Remember that stands for standard temperature and pressure. And if we go and flip back into our packet, there at the top of page 2, remember that standard temperature and pressure, which we can abbreviate STP, is either 0 Celsius or 273. We got rid of that decimal there and changed this to a 3. And of course, we're going to use the Kelvin version. So this tells us, just with those three little letters, that our T2 is 273 K. And then our standard pressure is also going to be our P2, but we have to choose one of these, and it's not as easy as choosing between Celsius and Kelvin, where obviously we'll just always choose Kelvin. Here, the way we choose between these numbers is by making sure, like we said from the beginning, our units for our pressure and volume have to match. So if we go back and we look at our pressure 1, that was in kPa, so I'm going to have to use this standard pressure that's in kPa. So 101.3 is going to be the P2 that we use here because it's in kPa. That's the only reason. Well, first, it's our standard pressure in kPa. So that's all of the numbers that we should need at this point, and I'll even clean this up a little bit so that you're not distracted by all that. So these are our values that we need to be plugging into this equation now, and this is where I'm going to stop working it out and setting it up. I want to see if you can take these numbers from the problem and put them in the right place in that equation, and then follow it up with that same cross multiplying and dividing that we've been doing. And this number should end up being just over 47, but once we round it to 2 sig figs, we'll have 47 as our final answer. That's the last one that really has any tricks in it. Number 4 is scary to some people because it has a really big, crazy scientific notation number here. But if it helps you to just think of this as 10,000, actually no, 100,000, because we need to move our decimal 5 times, making this number bigger. So that's going to be adding 5 zeros at the end. So it's a scientific notation is tripping you up. Just write out 10,000 as your number of liters, and it's going to make your answer be pretty big, crazy big. But it is going to work the same way as the rest of our problems do. This one is going to be a little bit shorter and simpler than even some of the other problems we've been working that you thought were short and simple, because we're actually going to get to leave out 2 variables here. Not just n, but also something else. And same kind of thing on question number 5. A lot more words, but not very many numbers to work with. I will reassure you that you can use milliliters. You don't have to have liters here, so your answer will be in milliliters as long as you put milliliters in. If for whatever reason you do decide to turn that into liters, then your answer will just match this liters answer that I have here. So I'm going to end by putting up those answers on the screen again, just so that you can make sure that you're checking your answers and seeing these unrounded answers, especially for number 4 with that huge, crazy number there. But hopefully cross multiplying and dividing is right up your alley. So come in and let me know if you have any questions or issues setting up and working out these problems.